Hello everyone, this is Ayushi Pal. Along with my teammates Aditya Singh and Priyesh Seni are going to implement the project on the topic detect human activities with the help of smartphone dataset. Next slide. These are the agenda. Introduction and background will be covered by me. Description of dataset and feature section are covered by Priyesh, and the rest of the topic will be covered by Aditya Singh. Next slide. Here comes to the introduction. Since the topic of our project is the human activity recognition, so there are basically we are using the smartphones to detect the activities, and as we know that many of us are using smartphones in our daily life. So with the help of smartphones, we are going to measure the position, movements, and orientation of a human being. The main objective of our project is to recognize the human activity with the help of accelerometer and gyroscope. In accelerometer, uh, there is a time series signal. With the help of that signal, we are going to detect the human activities. Here, the activities detected are basically standing, sitting, playing, and etc. Here we focus mainly on the activities like standing, sitting, and walking because there is a great human physical activities. This application can be beneficial as we can say in terms of medical and for the elderly people. This project falls into the scope of activity recognition. In this, we are going to use the wearable sensor with a very low cost, and that can detect the human activities at a very high accuracy. And for this, we are using active learning models to detect the activities, and after that, comparing with all other labeling algorithms. Here comes the sensor activities. To detect any human activity, we are going to use many wearable sensors like for detecting the temperature, body temperature, motion, heart rate. For that, nowadays, everyone is using the smart band. With the help of that, we can measure many human needs like heart rate, body temperature. With the help of that, we can detect any activity. Next slide. Accelerometer. Accelerometer is basically used to detect the experienced physical acceleration of an object. It's generally used in measurement of like vibration in machinery, acceleration in high-speed vehicle, and etc. Its main principle of operation generally consists of seismic mass, due to which displacement is done and it can be related to acceleration. Here, the displacement can then be converted into electrical signal, and with the help of that, we are going to detect. Now comes to the gyroscope. Gyroscope is a sensor that can provide orientation information as well as with the greater precision. It is used in many applications like inertial navigation system, etc. For human activity recognition, this sensor can be used for various tasks such as detection of various transitions between postures and for detection of activities. This scatter plot here is a scatter plot which can define like in the first figure we can see that there are many activities like red one is showing for something, and yellow one is showing some other activities. Now with the help of gyroscope or some we are detecting only the three activities, basically standing, sitting, and walking. So we can, by the use of filter or any other things, we can detect many, like we can detect many other activities. And after that, we are using smartphone as a wearable sensor. Uh, the, we are using basically smartphone because everyone is using smartphone and it is a daily basic need of everyone. So in this, it will suggest all the changes happening in the body of the human, and it will process information and then interaction with the environment. Now description of the data set will be covered by Yash.
Thank you, Ayushi. Thank you so much. So the next part of presentation is description of data set. Let's look at what our data set looks like. So we are using HAR dataset, which means heterogeneity dataset for human activity recognition system. So on this dataset, we can do several activities. For example, classification model can be produced. It can be used for data segmentation and sensor fusion, feature extraction. So all this activity can be done. And this dataset consists of mainly 4 files, which is coming from 4 sensors. We are using 2 devices, which is watches and smartphones, as described by Ayushi above before. So we are using 4 smartphones and smartwatches and 8 smartphones in total. So in these, there are 2 sensors, which is accelerometer and gyroscope, which from which all this data is coming down. And the activities labeled to them are biking, sitting, standing, walking, climbing up, and climbing downwards. So all these sensors are tied to different subjects, and those subjects are labeled as those 9 subjects are labeled as from A to I consistently across all the files. So this is what data looks like. We can see there are different labels here. Arrival time is given, creation time is given, user, model, devices, and GTV is the ground truth. And XY, the most important data here is our XY, and Z coordinates from which we will build our model, and then we'll compare it to the ground truth, which is provided in the last label. So let's understand what is going on here. So the most important task in any machine learning or deep learning model is basically feature extraction, because what kind of data you will use will give out the result, and its accuracy will depends upon what kind of data set we are using. So first of all, we have 3 X, Y, and Z axis data. So these are coming from accelerometer and gyroscope. So we have labeled them T accelerometer XYZ and T gyro XYZ. Now these signals are coming from transducers, because basically this gyroscope and accelerometer are transducers. So they are giving output signal in terms of analog signals. So it is very difficult to store them. That's why what we are going to do is convert them into a digital signal using sampling. So here we have used sampling frequency of 50 Hertz. Now these digital signals are then filtered using median and third order low pass Butterworth filter with a corner frequency of 20 Hertz. And after that, so this filters were used to remove the extra noise signals. Now again, one thing is the acceleration of an object depends upon gravity too, because gravity has a huge impact on it, because the acceleration due to gravity, the factor of 9.8 will come out. So we have to differentiate between the body acceleration and acceleration due to gravity. So once again, we will use low pass Butterworth filter to differentiate the body acceleration and acceleration due to gravity. And for that, we will use the corner frequency of 0.3 Hertz. So after that, what we will do is we'll measure the body's linear acceleration and angular velocity, and then we will derive if there are any sudden jerks in the movement of any subject. So if there are any jerk, we will label them under the T body acceleration jerk XYZ and T body gyroscope jerk XYZ. Also, the magnitude of these signals were calculated using Euclidean norm, and all the derived features that we have got from this data set is labeled here, this P body acceleration magnitude, P gravity acceleration magnitude, P body acceleration jerk magnitude, P body gyro magnitude, and T body gyro jerk magnitude. So all these acceleration magnitudes due to body and acceleration due to gravity are measured here. Finally, what we will do is convert all these time domain signals. Earlier, what we got was time domain signals, and now we will convert into frequency domain signals using fast Fourier transform. The basic equation of fast Fourier transform is given as mentioned in the figure below. So now we will outline the what is the process of doing this model. So this is a generalized procedure that will be used in all kinds of deep learning or machine learning models. First of all, we are gathering or collecting data from smartphones. So this is our data acquisition layer, and then this raw data is saved. Then this data coming from a smartphone is saved into a server, which we are labeling them as a raw data. Here, this raw data is basically data set we got from for our purposes, which is HAR dataset. Now, the next step is pre-processing layer. In this data, in this process, what we'll do is we will handle the missing values. Suppose there will be a lot more missing values. It might be due to the corruption of a sensor or inefficient working of sensors. There might be some missing values. So we will handle them in this process. And finally, the normalization process will be done, because normalization brings all the data into similar ranges. If there are data from different ranges which varied according to, suppose let's say they are very small numbers and very big numbers, so it will create a bias in the system. So to avoid this condition, we will use normalization process. The next step is exploratory data analysis. Now this is mostly a visualization process. Visualization process, because it is easy to understand the distribution of data in a visual form as compared to the tabular form. So what we will do is we will figure out what are the important features that is necessary to build our model. So in this process, we will visualize all the data distributions that what are important for us. Finally, after the data is prepared and processed, it's final time to apply the algorithms. It can be different algorithms, as will be discussed by Aditya. We have used three different models for a model, three different algorithms for a model. Finally, the most important part is accuracy evolution. Once the model is developed, its accuracy is measured in terms of various performance indices. In terms of, in case of prediction, in case of time series data, mostly used in accuracy evaluation matrices are RMSE, which is root mean square evaluation, R square score, and validation curve. So this is what basically a machine learning or deep learning model looks like in general. So the next part will be covered by Aditya. Aditya, please take over.
Thanks, Priyas. Then I am discussing how the model works and what are the databases required for the models, and what are the database stage, and how much users use for the database, like how many people are working to bearing that gyroscope and accelerometer, and how many samples are working at the same time and same frequency analysis. They have I am taking the one database. They have have different axes of X, Y, Z. They have give the different values of the statistics, how they work. Like I'm taking the example of the at their database, they have X, Y, Z, what are saying that. Then the example of walking up and down stairs. Basically, mainly all the things are working in walking and standing and sitting. Then and at the walking, Z axis shows the capture forward movement of the leg when we are going to forward. At the how the movement of the leg are working, that gives the shows from the Z axis. And at the y axis shows the upward and downward motion of the human. They are capturing by the y axis, and Z x-axis are the capturing the horizontal movement of leg, how the horizontal movement of legs are recording. And next slide, please. Next slide. And next Friday, we are investigating the how the participant are activity in per hour user. When simply we are taking the database of the user, they are working the per hour. Like they have how to predict the database, how to pre-processing occurs, how to eliminate the noise. Like some database have the overfitting some values of the data, that how to reduce them, how to pre-processing by the using of threshold method and some kernel use of all that. They have that have the giving one data provided to user for our simply giving the one database. Then here are the 6 activity are working. Then checking the count of the every hour give the subject 30 people are working. 30 people have been using the variable, uh, and they have the 60 minutes. They have count the every 20 minutes steps of the sitting, standing, laying, walking downstairs and up the stairs, and assuming all the number of downstairs and upstairs are the similar of the length, like they are equal number of the stairs. Please next. The way we are taking the activity of these per hour, there we are finding the how to fluctuation are coming from the counting the labels, and they have the generally distributed equally. They how to walk the same number of stairs as when we are talking when taking the assuming at the all stairs are same length, but when we are going to upstairs, they take the some time more to come from the downstairs, like their time series analysis. We are talking about the time series analysis. At the time series analysis, accelerometer gives the upwards value is more than the downwards walking stairs. Then they have the give the 10% more faster of the value. Then secondly, the future engineering by the domain knowledge. They have the two type. They are 60 activities are different dividing in the a 3 to 3. Like one have the static activities, one have a dynamic activity. Static, like we are sitting in the chair, we are laying on the bed, and we are simply stand and nothing do the else, like only stand and watching anything. They have the static activities, and after that we are assuming 3 activities like walking upstairs, walking downstairs, walking, have the movement, recording all the data to that of the data point business. Then here the I am taking the how to moving activity as giving the more accurate value, because they have the covering all approximately all values up to 90 to 95% of the motions are covering in within them. But when we're talking about the stationary activities where they have the simply laying down and standing at the simple point, then they have less movement of the any activity have the occurs. That's why only some point of values are coming. They have the how to extract that point. They have the they are not useful for the any activities. That's why they're neglecting the stationary activities for the our project. Next. Simply they are I am taking two graph of the moving activities at as well as the compare the stationary activities. They have the taking the how much data compared how much got the exact data at the stationary, or how much covering the data from movie activities. Business. Then we are taking the accelerometer. They have the accelerometer have these simple values of the they have the mean values, standard deviation values, and they have the one equidal distance between the user how their motion or works. They taking the average value. If their average values, if their mean value is if the mean value is less than 0.8% minus 0.8, the activities are saying the predict the data is standing or sitting or laying. If the accurate accelerometer mean which value is greater than minus 0.6, then activities are either walking off downstairs or then upstairs. If it's less than, is it greater than 0.0, then is give the value of the walking downstairs. They have the classify and predict the all the data approx 75% activity with the layer hub. They have the sometimes it occurred some errors because they did not get perfectly data because of the overfitting. This next. Yeah, if the position of gravity acceleration in compound, they have the standing divide the x, y, and z values. X, y values are versus of the gravity mean. They have the standing, how to stand, then how much angular velocity as mean value is coming, angle between the users, and sitting, laying, and taking about the all the values. They have the shake angle and gravity mean. As if the is laying, the how much value, if is not laying, the how much value. Simply we are talking about how to work. First we are talking about the simply I am giving one example for each them. First step is the sensor signal processed by the applying of the noise filter. Again, when any signal are coming, then have this some noise at the any deep learning method have the one pre-processing are occurring to avoid the signal noise. They use this noise filter. They have the noise free of the signal. After that, the second step of the our project is calculating the windows and selecting the features by the help of the time and frequency analysis. And after that, the next step is used for the accelerometer. The accelerometer signal divided into body and gravity using the low pass filter. We are using the low pass filter, and they have the body weight and the gravity of how much gravity are occurring at the body weight. Then divide this signal according to them. After that, two main value are occurring: the linear accelerometer and the angular velocity are between them. Here they are working the moving the parts of leg and hand and everything. They are opting this. Sometimes it's happened the jerk of this signal because the user are not working properly and they have the not predict the proper data points. They have the one noise occurring. That's a normal jerk signal. Then how to avoid the jerk signal? Simply taking the magnitude of 3D signal and calculate their euclidean mean. Euclidean mean, how to calculate the euclidean mean? Then how to calculate is simply one formula. To, when one user have the different point and another user have different point, they have the simply plot the one see straight line between two users, and they have the formula of giving the simply formula of Gaussian function. By the help of Gaussian function, we are taking the formula of Euclidean distance and calculate the Euclidean mean between them. And they have the after that, when we are taking the Euclidean distance, then we are going for the frequency domain. And where the frequency domain, we are the help of the FFT signal. We are calculating the exact what of the motion are working by the users. After that, calculate the mean standard deviation and comparing the largest value of the user data point and lowest value of the user data point, and comparing between them and decide the what is the working by the users. Then please next slide. They have the two types of the data is used. First is the KNN algorithm. The KNN algorithm is by the we are helping by the one taking the one example, and they have to taking the 20 users at the time. They have working. We are dividing this 20 is they have the blue line working the when we are the upstairs, and red when we are going for the downstairs. They gives the value of the prediction how much is KNN useful for that. Next slide, please. After that, KNN have they didn't give the more accurate values and more prediction of the how the working are going on. Then we are going for the TSNE model, algo model. Then the TSNE model, algo model, they have the use the 5 major working processes. they have the first process is logistic regression, in where logistic regression, their linear classification is used. That possible is it's give the single trier basis logistic function. They have this sigmoid function. They give the real input. They take the real input or give the output of 0 bit and 1 between the 0 and 1. They have to give the 95% accuracy rate of the results. After that, when but in the logistic regression, sometimes data have not accurate. They have the overfitting problem. Then if the overfitting problem occurs, then how to remove that? The one algorithm is used for TSNE is they have the regularization. Regularization is simply you will take the big data points and they enforce in them into the small data points. Do then calculate the variance between the all data points. And if after that the overfitting is avoiding, then it's give also it gives 96 point frequency accuracy rate. After that, one TSNE algo is used. That name is linear SCV. Linear SCV support Maxent classifier, software vector classifier. They have the also used for the predicting the classes of the data and like give making the different data, and they're like standing, sitting, walking, and all things are making about them. After that, they have the random forest classifier. They have the using TSNE. They have the 86 point of accuracy rate, and they have depend the vector peak of the independent value. They have the, I am taking one result from the when we are have the iteration rate is 1000 and perplexity is 5. Perplexity means the ability to deal with how to understand something. They have the first result is when we are taking 5. They have the 6 activities at different. They have the like sitting is blue and red is walking, yellow is walking downstairs and dividing after them. Next slide, please. When we are taking the perplexity at 10%, they give the more accurate result. They have the standing, dividing the standing alone and two blue lines, and sitting different, and yellow is giving the stairs and give more accurate value from the when we are taking the perplexity 10. Next, please. Next. Okay, this is my model. They have the one how to iteration rate is perplexity is 50. We are taking the perplexity 15. Then all the 6 activities are dividing, but different values are predicted, and they give the more accurate value. But they have the one how much iteration are occurring. How much iteration means only how when we are learning anything, how much required time, how many times we are going to process to learn these some things. They have the at here we are so the like all the yellow points about walking upstairs and walking downstairs. They have the walking and they have the leaking. But next they have the confused at here. When we are talking about the result and conclusion, they have the we are taking the trained data in the 2 classifier. They have the KNN and TSNE. Then we are deciding the best classification in TSNE because they have the gives the 90%, 92% of the value, and the KNN is give the 82% of value. In our observation, that TSNE is more orientation and position of the smartphone gives the better accuracy rate to near west. And when we are talking about the future scope, because in the TSNE 2 models are not clearly mentioned. They have confusion metrics. They get confused in metrics. They have the how to standing and sitting activity, because at the standing and sitting activity, the prediction of data is not giving more accurate value. There's a future aspects value of for the our project. We are implementing for the further that. That's a total conclusion of my project. Thanks, everyone.
So thank you, Aditya. It was a wonderful explanation. So I hope the viewers got the idea what our project was. It was basically the posture detection, and there were in the past several algorithms have been used, but the accuracy was not up to the mark. We have tried our best to bring our accuracy to up to 90%. If in case there is any improvement, we will try it and update you regarding the same. So it was nice to discuss this project along with viewers. Thank you so much, all of you.